The universe is a vast and mysterious place. For centuries, we have gazed at the stars and wondered about our place in the cosmos. We have made great strides in understanding the laws of nature. Yet some phenomena remain shrouded in enigma. Black holes, those cosmic abysses of immense gravity, are among the most captivating and perplexing objects in the universe. For decades, black holes were thought to be the end points of stellar evolution. They were seen as cosmic vacuum cleaners, relentlessly devouring matter and energy. But what if we could harness the power of these celestial objects? What if we could rebuild them, brick by cosmic brick? Recent breakthroughs in quantum physics have opened up exciting new possibilities. The once esoteric realm of quantum mechanics is now illuminating the most extreme environments in the universe. We are on the cusp of a new era, the dawn of quantum astrophysics. This new science holds the key to unlocking the secrets of black holes and perhaps even manipulating them. Imagine a future where we can not only observe these cosmic behemoths, but also engineer them, shaping their properties and unleashing their potential. The idea of rebuilding black holes might seem like science fiction. However, the theoretical foundation for such an endeavor is being laid today. Quantum gravity, a field that seeks to unify Einstein's general relativity with the principles of quantum mechanics, offers tantalizing clues. One promising avenue of exploration is loop quantum gravity. This theory suggests that space and time are not smooth and continuous, but are woven from discrete, indivisible units, like tiny loops of string. These loops, at the Planck scale, are the fundamental building blocks of space-time itself. In this framework, black holes are not infinitely dense singularities, as predicted by classical general relativity. Instead, they have a finite size and a complex internal structure. Loop quantum gravity suggests that the collapse of a star into a black hole is not a one-way street. It could be a dynamic process, with the possibility of a bounce back or a quantum transition to a different state of space-time. Another theory, known as string theory, proposes that the universe is made up of tiny vibrating strings. Different vibrations of these strings give rise to different particles and forces. String theory also allows for the existence of extra-spatial dimensions beyond the three we experience. These extra dimensions could provide a way to access and potentially manipulate the inner workings of black holes. While the theoretical frameworks for understanding black holes are being developed, the practical challenges of rebuilding them are immense. Harnessing the power of quantum mechanics to manipulate objects as massive and energetic as black holes would require technological advancements beyond anything imaginable today. Imagine, for instance, the need to generate and control extreme terahertz frequency lasers. These lasers, pulsating at trillions of cycles per second, would need to be powerful enough to distort space-time at the quantum level. We would need to develop materials capable of withstanding the extreme temperatures and gravitational forces near a black hole. Diamond ceramic composites, engineered at the nanoscale, might provide the necessary strength and heat resistance. Perhaps we could create quantum-generated shock waves. These waves, ripples in the very fabric of space-time, could be used to reshape the event horizon of a black hole, or even induce a quantum transition, potentially transforming it into a white hole, a hypothetical object that spews out matter and energy. The ability to rebuild black holes would be a testament to human ingenuity. However, it would also usher in an era of profound ethical and philosophical dilemmas. The power to manipulate the most destructive forces in the universe demands careful consideration. Should we even attempt to control such forces? The potential for weaponization is an obvious concern. A black hole, even a small one, could be used as the ultimate weapon of destruction, capable of annihilating entire planets. The ethical implications of such technology are staggering. We would need to establish strict international regulations and safeguards to prevent the misuse of this power. Furthermore, tampering with the fabric of space-time could have unforeseen and potentially catastrophic consequences. Could we inadvertently create a runaway black hole that consumes our planet, or even our entire universe? The risks are enormous, and the unknowns are even greater.